Solution set 19 is 1. Then do that problem. Let's see. Okay. Let's see. I haven't done any of these problems in here, by the way. So if anyone needs to correct me, go ahead. Uh, okay. First question. So the instruction, the register, the dependency. Okay. So is R3 used anywhere else? Yes. So 1, 2, 3, 4, 5, 6, 7, 8. Instruction 7 R3 from instruction 1, and then instruction 8 as well over here. Oh no, sorry. 8 is here. 8 R3 dependency on 7. What else is there? 4 over here. So instruction 4, register 4 uh, from line 2. What else is there? 5. Instruction 4 on R5 from instruction 3. What else is there? Over here, instruction 6 R4 from instruction 4, and instruction 6 make this smaller. Okay. Instructions 6 um, R6 from instruction number 5. What else is there? R4. No. Wait, did I start recording? Hope I did. Yeah, I did. Okay. Instruction 8 R3. Oh no, I did that already. Um, okay. And then this loop will go to here. So I have to write this out again. R5, R1, R4, plus R5, R6, R2, R4, minus R6, Y3, 3 minus 1, minus 3, 0. And then we have to loop this again. So R5, 1, 4, R4 plus R5. I should have done a different color. Okay. R6, 2. So, okay, Okay, so is there R1 used anywhere here? No. R4 from 3, 4, 5, 6, 7, 8. 3, 4, 5, 6, 7, 8. Yeah, when you have a loop, you have to check the dependencies for the loop as well. So this purple line is where like the loop like restarts. So because it goes from 8 back to line 3. So I wrote them out so I can easily visualize if it's used anywhere. So R1 was not. R4 is here. So this is instruction 4. Um, R4 from instruction 1. Oh, actually, no, did I do that right? Yeah. Instruction 4 on second loop has a dependency R4 from the line 6 previously. What else? R5? Anything? Um, yeah. So 4 on second loop. I'm gonna double check because I don't know if this is right, by the way, just so you know. R5, 3. What else is there? R2, not used. R4 is here, so don't care about that. R6 is here, don't care about that. R3, do I care? Yeah, over here, right? No, I don't, I think, right? Can something be dependent on itself? I don't actually know. How many dependencies are there? 1, 2, 3, 4, 5, 6, 7. How many did I write? I wrote too many down to 1, 2, 3, 4, 5, 6, 8. I wrote too many. What did I screw up on? R4 from R2 to from instruction 2. Okay, so that's right. 3 to 4 on R5. Yes. Uh, 6 to 4 on R4. Yes. 6 to 5. Didn't have that, did I? R6 on R2, right? Yeah. From 1 to 6. Do I have that? R3? That's a typo. 1 from 1 to I6 on R3. I typo. I think that was a typo. It needs to be 7, right? I think it needs 7. From 7 to 8 on R3. And R4. Oh no, my thing crashed.
Yo,
Yo, what's up?
not much.
What just crashed? What's up? Nice, bro. Oh, okay, so I had an extra one or something on what? Or five? Or did he forget to put it in? No, did I put an extra one? I'm not really sure. Um, I have an extra one, I think, but you get the idea for this. Um, all register and memory addresses have initialized to one bit, yeah, dynamic one bit, initialized to taken, full data forwarding. Okay, and no, okay, this part, okay. So draw the pipeline for a single loop. All right. So 1, 2, 3, 4, 5, 6, 7, 8. Then we don't have to write the rest, I guess, right? So fetch, decode. Oh, this is an R type, R type, load, R type, and branch. Fetch, decode, exec, no op, write back, fetch, decode. Is there any dependency? No. So exec, no op, write back. Now fetch, decode, exec, mem, write back, fetch, decode. Any dependency? Yes. Over here and over here. So, um, instruction 2 can forward that there, no problem. Instruction 3, load type just like the. Is it the same question as in the problem set or no? Looks really similar because you have to stall and then you can do exec. Exec, mem, like that. Fetch, have to stall here. Decode. R2, no dependencies. Decode, exec. Oh wait, I messed up. This should have been no op. Back. Pablo set was not taken. Okay. Uh, But then he says draw the pipeline for a single loop. Like, do I not show that it like loops after or what?
I don't think he would. Like, so it would end in like. However, I think this looks very similar to one in the problem set, and he just
Yeah.
added like 2 more instructions at the end. I have no idea why.
Mm. Fetch. Line 6 is there any dependency? Yeah. On 4, that's done. Line 4, line 5 is a load. So this one we have to wait again, and then back, no up, right back. Call the code. Line 7, no dependencies. Exec, no up, right back. So fetch decode. Any dependencies on line 7. Data forward, no up, no up. Okay. Do we have to, if it's a single loop, like, do we have to write the other lines, or what did he do? Let's see. He did.
Wait, right? The what?
He did write the next couple of lines. Okay, so I guess he means like the next 2 lines for the single loop. So
Oh yeah. What I think he does is he fills out the cycle completely. So if we go to like an extra cycle that fetches an instruction, he would fetch that at the end.
yeah, it looks like he just
Like
does the
even if
one
it's not
loop
part of
and
the
then
question.
the two instructions that would be fetched after the
Yeah.
cycle. Yeah.
Yeah. Now I remember. That's how he does it.
Okay. So we take the branch because it's Thanac one but taken. So fetch. Yeah, before exec. So fetch decode. Is there any dependency on R1? Nope. So fetch decode exec mem right back. Fetch decode. Line 4 has a dependency on 3. And line 6. Line 6 is done by the time this is running. Yeah, because line 6 was here. And then the other part is R5. R5 is going to have to wait to stall. And then exec. For,
I wasn't here for the beginning, but what are the R's and the L's that you're on the left side?
this is just like the types of instruction. R type, load,
Oh, gotcha.
branch.
Yeah, that makes sense.
Because data forward, it depends on if it's like a R type or an L type instruction.
Yep.
Okay.
The
So
R types can especially forward the data immediately
R type can forward the data after exec
after
stage,
execute.
and then for load instructions, you can forward it after the mem stage.
What's the difference between operand forwarding and then full forwarding?
It's the same. They're synonyms.
Okay.
Okay. So calculate the CPI. Let me see if the chart is right, actually. Let's see. 14. He didn't finish the chart. What a bitch. Eleven to 12. Did I do that? Oh, 11 to 12. Okay. Chart looks right. Calculate CPI. Okay. So the loop starts here, right? Maybe I'll use red actually. Okay, so the loop starts here. Uh, the overlap is until here, right? And then there's this part, and then this part. Is that right? How many times is this being run? Let's see, 100 times. Okay. 2 plus, this is still 6, 100 times 6, top, it's in column, 100 times 1, 2, 3, 4, 5, 6, 7, 8, 8 plus 1, 2, 3, 4. Is that right?
Mm,
Really? Did I fuck it up?
looks great.
Should be 10. Did I screw up the boxes? Probably did, didn't I? Well, maybe it's not. Is it a typo? What did I need to draw this out until?
It's supposed to stop at 8. Could it be?
No, I'm talking about for the CPI.
Give me 1 second.
I think I stopped at the exit. Um, this is a little bit different than the previous question though, right? Where was the other question? The idea here was same thing as before. There's this is unrelated, and then I drew a box for yeah, so for this question, like I drew the box up until this part because I don't care about the overlaps, right? This is for the problem set. I scrolled to the problem set. This isn't the exam question. And then in this was what was remaining. So my idea was, okay, I draw a box around uh, this many rows because that's what's looping. And then for how many columns you go, you draw a box around the columns that don't overlap with the next loop. So that's why this one was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then this was 1 and 2, and then 1 and 2, right? I thought that was the idea. And then, but you're saying that for this one, it's still 10 for the exam question? Because this one's like different. There's no shot that like this would be the same, right? So this first part is definitely the same. But then if I only do up to the loop where it overlaps, It starts overlapping from 11. Yeah, that's what I thought. So it's like you draw a box around what doesn't overlap, and then the last 4 cycles is what happens after, no? Why would you stop? But I'm confused why you would stop before the no op instruction on instruction 8. We still need to execute. Different loop still needs to finish. We don't execute, we don't know whether the loop ends or not. Oh, so are you saying that like for the loop, it's still the for the amount of rows it's this, but then to know how many columns you go out, you go all the way until the exec stage, like this, and then the rest is this. And then at the end, I guess, uh, after the exec, these would be flush, so you only care about this, right? It's so weird. Um, how do we answer Hmm. So for the actual box, what is this? Uh, didn't work. So for this, when we draw the box, do we go up to the branches exec stage when we draw a box around the stuff? Okay. Then +2. Okay. This is literally the problem set question, right? So we can skip this. And then what about this? This is a different question, right? Okay. Okay. This branches that. So this code is straightforward. This one. Um, assume each memory location and register have value 1. There's no branch prediction. Okay. So R2 has a 2, so it'll take it. So this line will not run, and this line will not run. Actually, yeah, these two lines of code, if it's non-pipelined, then they won't run. Okay. No. Okay, what about this? No branches. Okay, here. Let's see. R1, 0, 0. So it's not equal, so we don't take the branch. So every line of code runs. Okay. Uh, okay, so basically these codes you can't just like blindly count the number of lines because there's some branches, so you have to basically check um, which lines of code will run. So I just checked that for all the programs. Um, so for this one, R2 had a 2, so on equal, we take the branch, so we skip those 2 lines of code. This one has no branches, and then this one has a branch, but right above it, uh, we do itself minus, which would be 0, so it's going to be equal, so we don't take the branch. So this is not a loop. We just run down the lines of code. So uh, above, so above programs are currently loaded in memory. Calculate the total number of clock cycles the program will execute on a non-pipelined multi-programming system, no multiprocessing. So it's non-pipelined, and you don't have both multi-programming and multiprocessing, so it has to run one program after another. So it's 5 plus 7 plus 9 plus 8. That is, I'm just gonna leave it like that. 29. Okay. Uh, for this one, execute on a non-pipeline multi-program and multi-processing system, and there's 4 processors. So the worst case is everything gets scheduled on one processor. So it's going to be 29 again. Uh, best is the whatever is the longest here. So 9. And then calculate the CPI for program 4 on a superscalar processor with 4 of each unit required. So, okay, yeah. We have to pipeline. That means that we're just looking for any dependencies, I guess. Uh, oh, uh, okay, what else did he say? Everything is initialized to 1. Okay, I need 2 of these, right? Okay, fetch. Everything can fetch. No issues. Oh, but there's only 4 of each. Is that right? So far? Each there's 4 processors, so 4 things can be fetched at once, and then the next 4 can be fetched at once. I guess we would have to see if there's any stalls here, right? Bloodline. So it's still go later. Bloodline 7 still go later. If this isn't because of dependency, it's because you only have 4. So it's a superscalar pipeline processor, but you only have 4 of each unit. So you can't fetch 8 things at once. You can only fetch 4 things at once. Yeah, so they are up to 4, but there's only you can only fetch 4 things for for the 4 processors you have, or the four not processors, but 4 of the required components. So you can fetch in the code for all of these, and then you can fetch here, and then here, I don't think you can necessarily blindly decode if there's stalls here, I think. So let's see what dependencies are there. Well, we can do these 4, I think. What is this? A load, part-time? No, store. Uh, auto, load, auto. Fetch the code, exec, mem, write back. Line 2 needs the load to finish. So stall, exec, mem, write back. So that's why I'm saying like this one stalled, so like this one will have to stall here. This one can decode properly. Line 3, or there's no dependency there. So decode, exec, mem, no op. And line 4, or line 2. So stall, awful will finish after exec, and I can data forward here. Exec here. No, yeah, no, not after exec. After mem, exec here. Yeah, because line 2 is a L type, so it has to forward from them after the mem stage. Fetch the code, stall, exec. Um, no op, right back. So these 2 will stall as well, I think. Is this right so far? Does anyone have the answer key open? R1 is the finish after that. So stall, like Oh, line 6, no dependencies. So decode, exec, map, right back. Line 7, no dependencies. Fetch decode, exec, map. Oh, yeah, back. Line 6 and 7 have to finish for the last line. So, stall. Oh, no, no stall. Uh, yes, actually, stall until the map stage. And no, pick back. Why did I decode there in 6? As opposed to what? Actually, let me check if the answer's right. Let's do that first. Oh, wait, I have to count this. So this was 10 over 8. Let's see if that's right. Am I dumb? Did you not do this question? I always skip this one. That's right. 29 best. Bro, you didn't even answer that question or what? Dude, not me doing all that and then it's not even on the answer key. Yeah, I mean, this is the exam question, but it's not on my exam answer key. I guess it's not here, but it is in the solution. Next page. Let me see. Oh, is it this? Oh, I'm dumb. I'm blind as fuck. I only got 10. How did he get 13? Shit. Line 3 is fine. Line 4 goes up to 9. That's right. Fetch, decode, stall, decode, stall, stall, stall. 6? 6 right? I messed up. Why does this have to stall so much? I missed decode in 8th. And the dependencies are right here. So you can check. Um, line 6 because it's depending on 5. Uh, even even though it's here, we have to wait. Thought it was if it was like the source for the next line. Does it, the destination also count? Is this like that other thing like in like yeah, so it's like some like it was kind of like that thing in caching with like the stale data. Is it like that? Oh, I guess that makes sense because this branch will if you don't want to overwrite the data until it's done doing the thing, right? So I need to erase. Okay, so line 6 has to stall until it's done. And then I can do right back, right? Is that right? I missed the decode? Oh shit. When was I supposed to decode? Way before, right? Cycle 5. Can you decode right here? I think you can, right? Yeah, you can always decode it. Nothing waiting, right? Yeah, still decode that cycle 5. Okay. There's, wait, no, I messed up something else. Waits until this, and then fetch decode exec. No, right, no, mem, right back. Yeah, we can do it again. Let me just think about it first. R3, this R3, no, that's fine. Number 8 is dependent on R1. Okay, so stall, 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 decode here, stall, exec. That right now? Yeah, okay. So then for this, 13/8? Is that the answer? Okay, so let's do it again. Okay, so for this question, uh, there's 4 of each unit, so we can fetch 4 things at a time, and then we can decode 4 things at a time, no problem. And then the next set, we can fetch over here. I can't put decode because there might be stalls here, so I can't blindly put decodes here. Like, we have to figure out this part first, and then we can do stuff here. So for the first instruction, um, there's going to be no problem. So fetch decode exec mem right back. So over here we can decode, no problem. For the second instruction, the data dependency on the first line. So we have to stall until the mem stage can forward it here, and then we can do exec mem right back, right? So that means that if this is stalling here, this has to be stalling here, because if this was like processor 2, this is also processor 2. So it has to stall here and it has to stall here. Uh, for the third instruction, there's no data dependency. So this one can fetch decode exec mem no up, because it's a store. So that means that this can decode no problem. And then line 4 is anything being used. R4 is in instruction 2. So we have to wait until at least the exec stage to data forward it here. Um, I think we'd also have to worry about this, no? I don't actually know. No, right? Or maybe we do. But it doesn't matter because it's already done. So line 4 is a bar type, so fetch the code exec, no op, write back. So that means that over here we have to definitely stall here, and then we can decode here, and also we can decode here. Okay, so the first 4 instructions are done. Now we have to think about the 5th instruction. The 5th instruction is waiting on R1, which was from the 4th line. So we have to stall, 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 and then this one data forward to this. Uh, why did we stall line 4? Because line 4 had a data dependency on R4. So we had to wait for this to be able to data forward it to here. Um, okay, so let's data forward it to the branch. So no op, no op. And then line 6, we have to wait for this to finish. So stall, stall, and now we can do our exec. And this is an L type, so and write back. And for line 7, R3, nothing's using that. So fetch, decode, exec, and write back. And then for the last one, that's the dependency over here and here. So 6 and 7. So 7 is already done, no problem. But 6, we won't be able to do it until the mem stage. So stall, stall, stall. This will forward it to here. Exec, mem, right back. That right? No, I think I messed up something. Why are we forwarding E from 2 to line 4? Oh, is that what it is? I always, I screwed that up. So it needs to stall for another. My pen is not working. I'll have to restart the thing. It crashed. Yeah, I messed up. I forgot. I always get confused with the R type and the L type. Do you see? I guess I'll go for it here. There. Yeah, I see what you're saying. So instead of this forwarding from here, crap, we need to move everything to the right. So, and this will give it exec, no up, right back. So that means that instead of this, we have to stall, and then this will forward to this. No op, no op. right? Is that right? And then I think I messed up something else too, right? Line 6 is waiting on that to finish. So line 6 is waiting on line 5 to finish. So this has to stall, and then this has to stall, exec, no, not right back, like this. Right now it's right, I think. Yeah. What a freaking annoying question. I know. This is the question that he said that nobody in the class got right, right? Okay. Well, the answer is 13 over 8. So, oh, wait, what does this one say? Consider the following outcomes for execution of branches. Predictor. Provide the accuracy. Well, this is before when he probably totaled up to 100 points per exam, assume. This is probably only like a fifth of the exam back then. So, I mean, yeah, I guess. Uh, for given predictor, not taken, right? And then the outcome is not taken. So that's fine. Not taken. Wrong. So then this switches to taken, right? And then this is wrong. So this switches to not taken. And this is wrong. So this switches to taken. And then that's correct. And then this is wrong. So it switches to not taken. This is correct. All right, see if I'm. Let's see. Taken. This is wrong. Taken. Wrong. Taken. The accuracy was 1, 2, 3, 4. 4 out of 3, 4, 5, 6, 7, 8, 10. 4 out of 10. Strongly not taken. Good. So strongly not taken. This is wrong. So weakly not taken. This is correct. So strongly not taken. This is wrong. Weakly not taken. This is wrong. So now this becomes weakly taken. And that's right. So it becomes strongly taken. And that's wrong. So weakly taken. That's right. No, that's wrong. Sorry. Uh, so this becomes weakly not taken. This is wrong. So it becomes weekly taken. Then second line, weekly not taken. No, it's strongly not taken because it was right. It switches from here to here. So it was at strongly not taken, and then you check, it was wrong, so then it switches from strongly to weak. Yeah. So weekly not taken, it was wrong, so then become weekly taken. This is wrong. Oh, this becomes weekly not taken. The accuracy for this is somehow worse. 3 out of 10? Is that right? Wow. Okay. Memory equals 1, register equals 1, dynamic not taken, hold data forward. Okay. So R4 equals 1. Oh, yeah. Is it L type? R type, R type, orange, R type, R type, L type, R type, orange, S type, right? Yeah. And then R type. Yeah. So R4 equals 1, R3 equals 50, and then R2 equals 0. And then now it's asking R4 and R2 are equal. No, they're not, because 1 does not equal 0. So you continue. Um, R2 plus R4, so R9 equals. Does this even matter? Like, why am I even doing this? R1 equals 51. R6 is equal to 1. R3 equals 49. 49 does not equal 0. So go to label X. Okay. So this loop happens 50 times. And then address 0 is equal to shit. Who cares? And then R7 equals 2, right? And then we have to look at the fucking data dependencies too. Oh my god, these questions are so annoying. Um, I'm just gonna do it. 2, 3, 4, 6. All right. Oh wait, we said we take it, right? No, we don't take it. If it was single, it's a previous question. This one? This one? Yeah, what about it? If it was single cycle? If it was single cycle, you're asking, or what? Like if there's no pipelining? If there's no pipelining at all, this is just going to be 8 over 8 because every line of code runs one by one. If there is pipelining, it's going to be completely different. Yeah, if there's no pipelining, it's just going to be 8 over 8 for the CPI because every line runs one by one. Will it data forward? Line 5? Line 5 is a branch. Are you asking like if it was true? Oh, from line 4 to line 5, I did data forward. Yeah, right here. Is that what you're asking? 5 to 6? Well, no, branches don't data forward stuff because it's just a branch. You're not saving anything onto R1. You're just using it as an input. It's not an output. Um, but from 5 to 6, we had to wait for the branch to finish for the superscalar because we don't want to overwrite R1 before the branch is calculated at the exec stage. That's why we had to wait. Yeah, it's just to make sure that the branch will have the correct value to compare. So we had to wait for the branch to finish. That's why. Uh, Dynamically not take, and we actually don't take. So that's fine. And then the next time, branch are not equal. Sorry, wait. Yeah. We considering not to take the branch and we didn't. And then the second time, we're considering there's branch are not equal. on day one equal, so we do take it. Not taken, not taken. But then we have to fetch 5. So 10 and 11 get flushed. Okay. Five and 6. Okay. So for this question, fetch, decode, exec, mem, write back, fetch, decode. Any data dependency R4, but we can wait the load. So stall, this one forwards, exec, no up, write back, fetch, stall, decode, 930. Any dependencies? Nope. Exec, no up, write back, stall, fetch, decode, line 4, R4 and R2. So line 1 is done. R2 was the previous line. So forward this because it was an R type instruction previously. So exec, no up, no up. We fetched the next 2 lines because it was dynamically not taken, and that'll be right. So fetch decode, fetch 5, R2 and R4. Well, it's already done by then. So line 5 can run properly. Fetch decode exec, no up, get back. Line 6, R3 and R4. It's done already by then. So fetch decode, exec, no up, get back. Line 7, fetch decode. R6, no dependency, so exec, mem, right back. Line, line 7, line 8, R3, already done, right? Fetch decode, exec, no up, right back. Fetch decode. Line 9, the branch is R3, so it has to data forward this. Exec, no up, no up. And then it'll fetch this and this, but then it'll flush them out because it actually did need to take the branch. So it'll fetch the right thing here. Yeah, it's dynamic. So the first one, it was not taken, initialized. And then we actually didn't take it because this was a, if only if it's equal, you take it, and we didn't take it. And the second time, it's a not equal, but this predictor is still at not taken. So it'll fetch these 2 lines the first time, uh, but it'll get flushed out. Uh, so after, so the first line, it was not taken, right? And it was correct. The prediction was correct. We actually didn't take it. So it stays at not taken. And the second time, it's gonna be not taken, but it'll be wrong. So the next time, the second loop, um, it'll be taken. But we're doing the first loop right now in the chart. Okay, so we initialize with not taken, right? It says not taken. There's two branches in this code, right? So line by line, we run this code. And then we see that when we get to this first branch, it's a branch on equal. If it's equal, then we take the branch. That's taken, right? In reality. But our prediction is not taken, and in reality, we don't take it because the one is not equal to 0. So the prediction was not taken, and reality was not taken. So keep it at not taken. And over here, our this was our prediction. Let's say prediction actual. So this one stays at not taken for our prediction. The reality is that we will take it, but we're only drawing the pipeline for the first loop. This this will switch, but you'll only see it on the second loop. Yeah, it's still not taken the first loop. And then this reality was taken, so then our branch predictor becomes taken for the second loop when it goes from here to here the second time. But right now what I'm drawing in the pipeline diagram is for the first loop. Mm. Okay, so this is what I'm thinking. Let's see what this answer looks like. Desktop. Oh, this is the one where he had to do it, that whole shell on the chalkboard, right? Uh, this didn't load for me when I tried opening it. Is it possible to someone take a screenshot of that? Because it's some iPhone format. I think it's not opening on my laptop. 9, 7, 11. Cycle 14. 14 less than 12. Yeah, yeah, looks right. Okay, so put a box around this, and then a box around this. Oh, that box. Yeah, let me just see if I can do the CPI. I don't know. Okay, so the CPI. Oh my God, 5 instructions plus 50 times 7, right? Because this is 1, 2, 3, 4, 5. Oh, 5 plus 2, because it will fetch 5 and 6, but it needs to run 10 and 11. And then for the cycles, it's 5 plus 50 times 7 plus the last time. It will fetch 10 and 11. 4, because their last time 10 and 11 were on. Where did he go? Is that right? Oh, what's his answer? Dude, he didn't put it. Great. Anyone know? This plus 4 in the solution. Oh, let's see. 4 plus 5 times 50 times some shit over. Yeah, okay. Um, do we just literally write this, by the way? If he asks us this, total cycles times max time. Okay, so which part did you want me to explain? After the first branch. Okay, So there's two branches in this code, right? There's one here and one here. Initially, we predict not taken, right? What was the reality? Not taken, right? Because this is on an equal. Is it equal? No. So we don't take it in reality. So this stays the same. Our prediction stays as not taken for the next branch. Okay, so then this is the next branch, right? Our prediction still stays the same, but in reality, what happens? This says branch on not equal. Is it not equal? Yes. So in reality, we do take it, right? So this will change to taken when we go to the second loop, because you see how this label X goes up to here? That means this code will run 50 times, because if you see this over here, R3 minus 1, R3 was initially 50 here, and I subtracted 1. That's 49, 48, 47. This will happen 50 times. That's why I was like writing out what each line of code does, because you have to know that R3 had 50 to calculate the CPI. Swipe up. Yeah. So the second branch was taken. So then the other 49 times, 49 times this loop will happen, the label X branch, it'll assume taken. But the pipeline diagram I've shown for a single loop, this is only for the first loop. That's why uh, you have lines 10 and 11. Like the next time this would run, this wouldn't happen, right? Because the branch predictor would say taken, so it would just instead get fetch lines like 5 and 6 over here instead. And then at the end, when it finally does have 0 equal to 0 after the 50 loops, then it'll be like 5, 6. Those will be flushed instead, and then you'll have like 10 and 11. That's the exit the loop at the end. Uh, I might have done the math wrong, but I was assuming that like at the end, um, you'll have like lines 5 and 6 here instead, right? Those will get flushed, and then lines 10 and 11, right? Um, those will happen. Maybe it's not +4. I'm probably finishing soon. I'm pretty tired. I don't know if there's a +4 actually. I'm confused now. It might be I don't know how many lines. This will get flushed with the right lines of code. Might be 6. I had, oh, I did 1, 2, 3, 4 for here, I guess. But I'm not sure. I'm not really sure. So if we take a branch and like thereafter, we have to do. I'm not. Wait, hold on. So if we take a branch and lines are after, we have to do those before exec first, before the branch. You're talking about like how to calculate the CPI? Because if it's the CPI question, I'm not even sure. He's like really confusing on that. 9, 10, 11, 5, 6. Since there's a branch predictor, yeah, this is different than the other code where there were no lines after the branch. So that's why it's different. There's a line 10 and 11 after the branch, so it will have things to fetch it instead of the other question where there was no like lines 9 and 10 after line 8, so you had to wait until the branch executed to fetch the next lines. But here, since there are other lines to fetch underneath, we can fetch 10 and 11 right away um, after fetching for line 9. Um, Long branch prediction. What is this? I'm gonna stop for now. I might do the rest of this tomorrow. I'm not really sure because I don't know if I can understand the CPI thing. Okay, I'm assuming that I'm just gonna lose like whatever many points the question is. I might email him. I don't know. Anyway, is there any other questions I can answer before call it quits? The overlapping part, at least for the rows, that's easy because um, you already know what lines are looping here, right? That's like pretty obvious. So the box, at least row wise, is that much. Um, for the column wise, I'm really not that sure because it has something to do with the overlap, but maybe I have to like think about it. I'm like kind of tired and I like sit there and think about it, but like it's gonna be at least the cycles that are affected and like overlap with like the next or I guess it's that the ones that don't overlap with the next cycle. Is that what it is? Yeah, the box should be the number of columns that don't overlap with the next cycle. So if the fetch starts here, yeah, because the next cycle is here, right? Um, Sorry, the next loop. So I think that's why the box ends here. because we want to do 50 times the number of columns that don't overlap, like the exclusive number of columns. So if this is loop 1, and then this is loop 2, for example, yeah, does that make sense? Like, I think that's what it is. So I'm pretty sure it's definitely 5 plus 50 times 7, and then the plus after is what I'm not sure about, this part. Because this will still overlap with other code, and then the ones that like weren't overlap are these, which is why I had plus 4. You know what I mean? Like at the end, there's gonna be all of this overlap, and then the last 2 lines of code have to finish, just 4 more cycles here. That's why I did plus 4. I'm pretty sure that I'm right with the CPI calculation. If line 4 was for us to take in, we do 5 and 6 after, then flush. Uh, if it was taken, where did it say to go? Label Y, we would go to here. So yeah, lines 5 and 6 would not be would not be fetched. Wait, hold on. Line 4 was initialized to take. Sorry, do you mean the branch predictor is initialized to taken, or do you mean like the actual code ends up taking the branch? The predictor was taken instead. So here you want to say taken. The actual was not taken. So yeah, it would fetch instead of lines 5 and 6, it would have fetched line 11, and that's it. I don't think it would fetch line. There's nothing else to fetch because there's no line 12. So then line 11 would get flushed, and then you do 5 and then you actually fetch 5 and 6 after. Can we do taken? Oh my god, I'm gonna kill myself. Okay, sure. Let's see. Yeah, branch sucks ass. And he's definitely gonna test us on branch. That's like the most ass part. I use that shit. Oh, yeah, again, this will change to not taken. Wait, no, this will stay as not taken though, because the actuality is not taken. Okay, so not much would change, I think. Um, what would do and then after 4, erase. Okay. So, uh, line 4 is a branch. I'm going to assume that we take it. Label Y is over here at line 11. So, you fetch line 11. There's no line 12 to fetch. So, we fetch here, uh, decode here. We find out that our thing was wrong here, so it gets flushed. And then we have to fetch the right instruction, which is line 5 and 6 over there. Then fetch decode, and then fetch. It would look like that basically. Um, there's no line 12, so don't fetch that. Fetch line 11. After this branch finds out, then flush this, and fetch 5 and 6. And then I think the rest is, let's see, 5, any data dependency on 5. I don't know. But you can do the rest, I think, after that, right? It's just like what we were doing before. So, anybody else have questions? Okay. So, I'm gonna head out. Well, the CPI before I had whatever I had before. He changed the answer. What's the answer? What's the answer supposed to be? Plus 550 times 5. I'm pretty sure it should be 50 times 5. Is this from the answer key? This part? But this is assuming for what? Is this right? I don't think this is even right. Yeah, this is like a whole different pipeline on his answer key. So, like, if you look at the screenshot over here, he had 5 plus 7 times 50 plus some shit from when he did it in class. So, I don't know. I'll do it again and check. I don't know. But yes. Okay. I'm uh, yeah, CPI, fucking bullshit.